This is in your notes. The chain rule is what we call it. And the chain rule says this. If you have a composition function, say f of u of x, and you're going to take the derivative. The way we take the derivative of a composition function is as follows. We take f prime of u of x, and we multiply that by u prime of x. A lot of letters today, huh? Move on. There we go. So this is the rule. And what we are going to do is, in order to solve these type of problems, we're going to create what we call a graphic organizer. You guys know I'm a big fan of these type of things. And what I do is I put the outside function here, f of u. I put the inside function here, u of x. It's often easiest for people to identify the inside function. What do you think is the inside function here? 2x minus 3. Very good. Now, the outside function will be defined, instead of as a variable of x, will be defined as a variable of u. So, what do you think f of u is? U to the 4th power. The rule says I take f prime of u, and I multiply it by u prime of x. So what I need to do is I need to take f prime of u, and take u prime of x. What's u prime of x? 2. What's f prime of u? So there's a little trick here, though. Look at the rule. It says you take one and you multiply it by the other, but you have to put the u back in. So this is what I do to always remind me. I put an arrow. That means I substitute the u back in. It's my little graphic organizer. Helps me get the problems correct. I'm going to multiply these together. What's 2 times 4u to the 3rd? 8u to the 3rd, right? Which is 8 times what's u? 2x minus 3 to the 3rd power. That's what we'll be practicing when we get back. That is your answer. We'll practice that when we get back. Go get some brain food Friday. What's that? Right here? Well, I think it's easier to identify right away what the inside function is. So if 2x minus 3 is the inside function, then you have this thing, and that thing we call u. U is 2x minus 3. See it? U is 2x minus 3, so it's that thing to the 4th power. We multiply them together. 2 times 4u to the 3rd is 8u to the 3rd. And then you take this and plug it in for u. Okay, next one. What's f of u? 6u to the 5th. What's u of x? What's the derivative of 6u to the 5th? What's the derivative of x minus x squared? Now remember, you got to plug this back in. So I'm going to multiply these. I can distribute the 30 to both of these, can't I? So I'm going to get f prime of x is, I'll just write it all out, 30 u to the 4th times 1 minus 2x. So I could take the 30 times the 1, and I get 30 30 times the negative 2x is minus 60x times u is, what is u? X minus x squared to the fourth power. That's what u is. That's what goes in for u. I plug this into there. The rule says I take f prime of u times u prime of x. This is u prime of x. This is u of x, right? This is u prime. I have to take that and multiply it by f prime of u. That's what it says. That's the rule. Okay? Don't worry, you'll catch on. Look at number 3. What is f of u? And if you don't like to do f of u first, then do u of x. What's u of x? 5x squared. So f of u has to be everything else that's sitting around. It's going to be the outside. Yep, so negative 4 secant of u. So, well, what would you like it to be of? If it's of x, this says this is u. So what is u? It's that. So if you take this and plug it in there, we should get the original, right? So if we are choosing to use these variables, we have to use u. What is the derivative of 5x squared? 10x. What's the derivative of negative 4 secant? Negative 4 secant of u, tangent of u. We multiply these two together. And I get f prime of x is 10x times negative 4, negative 40x, secant of what? 5x squared. I'm taking this times that. The rule says I take u prime of x times f prime of u times tangent of 5x squared. That's my derivative. So you see why I put a u there? So then I know to substitute it back in. Otherwise, if you just put an x, why would you have to substitute anything back in? Multiply the bottom two by each other and substitute u back in. You see number 4 and you think quotient rule, right? We can do this problem without the quotient rule. And it's going to be much nicer. Negative 5 times x plus 5 to what power? Negative 7. What is u of x? X plus 5. What is f of u? Negative 5 u to the negative 7. What's the derivative of negative 5 u to the negative 7? Or 35 over u to the 8th. And then what's the derivative of x plus 5? 1. We multiply those together. The bottom two. We get f prime of x is equal to 35 over x plus 5 to the 8th power. We're going to be problem number 5 till tomorrow. 5 involves the product rule as well as the chain rule. Instead, we're just going to look at number 6, and number 6 is unique. Anybody see why 6 is special compared to the others? Sine squared, but there's something else. This requires the chain rule twice, and I'll show you why. Okay, chain rule twice. You may say chain rule twice, really? We'll do chain rule that is involved 4 times in this class. Okay, so we're just going to show you kind of a little snippet of what's yet to come, and hopefully this will connect a lot of your questions together. Oh, there it goes. Come on back, computer. There we go. So, what is the outermost structure? If you were to plug in a value for x, what's the first thing you would do? You would multiply by 3. Then you would, what's the next operation after you multiply by 3? You would then take the sign. After you take the sign, then you would square it. So the last thing that you do is square it. So that's our outermost structure. So therefore, f of u will be u squared. What is it that we are squaring? Sine of 3x. What is the derivative of u squared? In order to find the derivative of sine of 3x, what do we have to do? The chain rule. Sine of 3x. What is the inside? What is the outside? What's the derivative of sine of u? What's the derivative of 3x? If I multiply them together, what do you get? So this box has 3 cosine of 3x. That's the derivative. That's what I did. I used the chain rule twice to figure out this one. Now I'm going to multiply them together. What do you get? What's my constant? 6 times sine of 3x times I don't know if I've actually seen a problem on the AP exam that involves taking the derivative that doesn't involve using the chain rule. It is the most important rule that you will use moving forward to take derivatives, without a doubt. So we're going to practice this. Take out your worksheet. We're going to set the notes aside. What I would like you to do is I would like you to work on the 6 problems on the front. And for those 6 problems, let's see, where am I? Here we are. Those 6 problems on the front, I've already done the problems, and I have the answers ready to go, and I will box them. I want you to see if you can come up with the same answers. So this is kind of our checking for understanding, and after that, your assignment is to complete the back side. People ask, do I have to draw the boxes every time? No. It's just a graphic organizer to make sure you get started. For this part, I would like you to divide them up into boxes. Because if you can't do the problem, what do you think the first thing I'm going to do is? I'm going to draw the boxes. So it's a teaching tool, and we should hopefully know how to do it. So I'm going to stop the video, and I'm going to leave these up here so you can check your answers. I'll come around and help you if need be. But this is be a lot of practice for us today, tomorrow, Friday. Chain rule is big time.